says everyone can see and hear me. Okay, now what happened? Okay, hello everyone. We're just going to wait a few minutes and let people trickle in to join us at today's interdisciplinary talk here in the Faculty of Science at the University of Manitoba. Thanks for joining. Andrew, I'll just let you know I don't have a counter, so I don't know how many people have joined. Can you maybe let me know the answer to that?
Yeah, we've got about 50 so far, so I think you're good to start. People are trickling in.
Okay, I'll ask again in a few minutes and then see how we're doing and let people get settled in for a bit and then we'll get going. Oh gosh, now what's happening? Okay, guys, we're going to get started here today. I hope everybody's on to the technology and ready to go. I'm Steffi Baum. I'm the Dean of the Faculty of Science here at the University of Manitoba, and we're delighted to launch our interdisciplinary series for this year with Dr. Mario Livio. He was actually the first interdisciplinary speaker in the Faculty of Science series some number of years ago, because I've known him for a long time, maybe 30 years now since I first met Mario when we were both at the Space Telescope Science Institute in Baltimore, Maryland. He's an internationally renowned astrophysicist, a best-selling author, and a popular speaker. And I'm proud to say I've worked with him and published some scientific research with him. He's a fellow of the American Association for the Advancement of Science, and he's published more than 400 scientific papers on topics ranging from dark energy and cosmology to black holes and extrasolar planets. He's the author of 7 popular science books, including The Golden Ratio, which was an international bestseller for which he received the Peano Prize, and the International Pythagoras Prize. His book, Brilliant Blunders, was a national bestseller in the US and selected by the Washington Post of one of the best books of the year. Fortunately, he keeps writing new, fascinating books, and we know he's an excellent speaker, so we're delighted to have him come talk to us about his latest publication, Galileo and the Science Deniers, which was published in May 2020 and received rave reviews in the Washington Post and the London Times. I'm sure we're in for a real treat today. So I'm going to hand over to Mario. He's going to give his talk and then we'll have questions. And I think, hope everybody knows how to provide questions. Has that link been provided, Andrew? So people know in the or when we get to the question period, we will post that link again. That's the link where you go to post questions, but we'll hold questions till after the presentation. Okay, thanks. Here we go, Mario.
Thank you very much for having me. So if we can go back to the presentation. I'm not sure why this, okay. Does everybody see that? Can somebody just answer it so that I know? Andrew, can you give me an answer? Yeah, okay.
We're all good.
Good. Okay, so Galileo and the Science Deniers. Galileo is one of those larger than life heroes of our intellectual history. And as a result of this, even many works of art were devoted to him. And I want to show you a little bit of that. I collected a few paintings, for example, in which he appears. And, just like, you would take photographs and look at them and throw one on top of the other, I will do that a little bit. So this is the very earliest portrait of Galileo that we know of. This was painted by an unknown Tuscan artist. You may notice, here he was maybe in his 30s or thereabouts. You'll notice that there is an asymmetry to his eyes, which was always there. In fact, in the last 4 years of his life, he was totally blind. Here he's maybe 40 years old or thereabouts. This painting is attributed to the son of the famous painter Tintoretto, who is also known as Tintoretto, but it's not sure that he painted it, but that's a painting from later in his life. This is the most famous portrait of Galileo, was painted by Sustermans. It's in the Uffizi Gallery in Florence. You see here Galileo with a telescope in his hand, for which he became, of course, very, very famous. But there are other paintings that show him in action and in otherwise. For example, here he is supposedly demonstrating the telescope to the Doge of Venice. Actually, he got a salary from the Venetian Senate for letting them use his telescope. But Galileo is so famous that, not just classical painters painted him. His portraits appear even in cartoons. This is actually from just this past century, for him showing to people from the Inquisition his things and explaining them to them. Here he is in old age, explaining again to somebody. He looks like he is blind in this minute here, and even he made it into pop art. Pop artists, they took a known portrait of him and created this pop image of him. And when I write a book, I like to go to the places where the people I'm writing about worked and lived. And so in this case also, I went to Florence, where he lived and worked. And I was actually the Galileo Museum in Florence hosted me, and they allowed me to use their extensive library and all the materials they have. But in walking through the streets of Florence, I discovered that Galileo is so famous in Florence that even graffiti artists do painted things of him on the wall. This was on the wall of a building in Florence. Of course, Galileo never wore these diving glasses, but it's nice that street artists also paid attention. But it's not just painting. In other ways, he was honored in various different ways. Google, when we celebrated 400 years to the telescope, Google devoted one of their doodles to this invention of the telescope. And there were other types of tributes. For example, there is a play written by a famous playwright, Bertolt Brecht, which was called Life of Galileo, and this is an image from that play. And there is even an opera, believe it or not. Philip Glass wrote an opera called Galileo, and I will let you even hear now, maybe 20 seconds worth of the sound from that opera. It demonstrates him doing various of the experiments that he is known for, and you will hear also the sound. So here it is. So you saw here a few of his experiments in mechanics, and the last one, arrangement of lenses to create his telescope. But I will come back to all of those a little bit later. Now, because Galileo was so famous, like with many famous people, there aren't just only true stories about him, but there are also many myths or, legends, that some of which may have been true, some perhaps not. So let me just mention a few of those. So one is related to this lamp that hangs in the cathedral in Pisa, where he actually started his education. His first biographer and student, Vincenzo Viviani, tells us a story that when Galileo was 19 years old, he watched this lamp in the cathedral, and this lamp was sort of swinging from side to side. And the story is that by counting his heartbeats, he saw that the period of the swing is constant, and then that he used this fact to create an instrument that would measure the human pulse. Now, people are not so sure about this, even though it was painted in various paintings. Here you see young Galileo supposedly looking at this lamp, or even though the lamp is, of course, painted here differently. This is actually in Florence today. You can see this painting. It's on the ceiling of a museum, a science museum. Yes, so the story is very nice. There is a small problem with this story, and that is that lamp in the cathedral in Pisa was installed only 4 years after the time when Viviani tells us that Galileo watched it. Now, it's possible, of course, that there was a different lamp before that, but it is quite certain that Galileo did not develop that instrument to measure the pulse. And the reason I say that is such an instrument was actually developed, and Galileo was usually very, very aggressive when not given the credit, but in this case he didn't say anything, so it's probably not something that he invented. What is true, though, is that he did experiments with pendulums and measured times and so on, but he did this later, not when he was 19 years old. A second story tells us that Galileo dropped balls of different weight from the Leaning Tower of Pisa. Now, why would he do that in the first place? Well, because, you see, at the time, the theory about free-falling bodies was that of Aristotle, which said that heavier bodies fall faster than lighter bodies, and in fact, that they fall faster proportional to the weight. So that, for example, Aristotle would have argued that if you drop one ball that's twice heavier than the other, then it would fall in half the time of the lighter ball hits the ground. Galileo thought that was wrong, and he even invented a clever thought experiment to show that that was wrong. And he actually did experiments with dropping bodies from different heights. The only thing is, there is really no documented evidence that he did it from the Leaning Tower of Pisa, even though there are actually books describing the experiments done at the time, and they don't mention that. But still, this didn't prevent people from painting this, and here Galileo is painted dropping those balls from the Leaning Tower, even in the presence of the Grand Duke. So this particular experiment probably never happened, but it did drop balls to determine how they fall. Finally, there is perhaps the most best known myth about Galileo, and in a minute I will explain why I think it's a myth, and that is that at the end of his trial, when he was claiming, and we will return to that, he was claiming that the earth moves around the sun, while at the time the Catholic Church insisted that it was the sun moving around the earth and the earth stands still. And he was tried for that. And legends says that after he was convicted and forced to admit that the earth doesn't move and stands still and the sun revolves around it, that when he stood up from his knees, he stamped with his foot and said, "And yet it moves." Of course, not in English he said, "And yet it moves." He said in Italian, "Eppur si muove," which means, "and yet it moves." Now, I spent a whole year researching this particular story, because the story said that it came from a certain painting, which is identical to the painting you see here. And on the wall there, you can see there is a drawing of the Earth moving around the sun, and the words "Apur si muove." The problem is that the story was that the painting in which this appeared was painted only 2 years after Galileo's death. And I have shown that that particular painting is most likely a copy, actually a late 19th century or even early 20th century copy of a painting, which is the one you see here, painted in 1837, so long after Galileo's death. And so what is the result of that is that the very first mention of this motto, and yet it moves, is shifted to more than 100 years after Galileo's death, in a book by an Italian, Giuseppe Baretti, where it appears. And, you know, when something appears more than 100 years later, it most likely is apocryphal. Now, I will say, though, that there is absolutely no doubt that Galileo thought that way. Yes, he absolutely, was very, very upset about, having to recant his life's work and so on. And he resented this fact for the rest of his life. So it did remain, and is still today, a symbol of intellectual defiance, where you say, well, in spite of what you may believe, these are the facts. And that is actually a motto that I feel compelled to use many times even today, even though Galileo probably never said it and just thought it. Let me now go to Galileo's actual discoveries, as opposed to myths. So one thing, he did want to study free-falling bodies, but you see, at the time, they did not have good time measuring devices. They did not have good clocks. And, bodies that fall not from very large heights, they fall very quickly. And it was difficult to measure small differences in the falling time and things. So Galileo thought of this extremely clever idea of, instead of dropping bodies like this, to roll balls down an inclined plane. And by making the angle of the inclined plane very small, he effectively kind of diluted gravity, if you like. He made the motion much, much slower, and thereby he was able to measure the times much more accurately. So this was a clever idea, and here is again a painting demonstrating him rolling these balls down an inclined plane. In fact, the angle which he used was much smaller than even the angle shown here. And he discovered via these things two extremely important laws, if you like, which later formed the foundation on which Isaac Newton formulated his laws of mechanics. So one was the fact that Galileo discovered that in free fall bodies, the distance that they travel is proportional to the square of the time that they fall. In other words, if you drop a body for 1 second, or you drop it for 2 seconds, when you drop it for 2 seconds, it travels 4 times farther than in 1 second, which is 2 squared. If you drop it for 3 seconds, it travels a distance that's 9 times the distance it travels in 1 second. So this was the first sort of, if you like, very mathematical law of mechanics. And the second thing that he discovered was, by allowing bodies to roll down a plane but then actually fly in the air, he actually looked at the trajectory that projectiles do in the air. And by observing many such projectiles in the air, he discovered that they trace a curve that was known since antiquity, which is a parabola. So he discovered that projectiles in the air, they follow a parabolic path. And that was, again, another mathematical law that he discovered. And in general, he was responsible in some sense for the mathematization of physics, namely that to express the laws of nature, you use the language of mathematics, which was incredible intuition on his part, because no such real laws were known before him. Of course, his greatest discoveries came with the telescope. And these are two of his original telescopes that remain. They are also in the Galileo Museum in Florence. Galileo did not invent the telescope. The telescope was invented in the Netherlands. But as soon as he heard that the telescope was invented, he immediately started constructing his own. And at first, what he did, he basically took organ pipes and put two lenses at the two sides of the organ pipes to create his first telescopes. Now, he also polished his own lenses. And here in the middle of this ornate frame, you can see one of his original lenses. And because he polished his own lenses and constructed his own telescope, he was able very, very quickly, the available telescopes at the time had only a power of about 4, they magnified 4 times. He very quickly reached telescopes that had a power of more than 20. So with this, that allowed him to do really the big discoveries that he did. And, he had a telescope in his hand, so what do you do with it? Well, maybe most people would have, I don't know, spied on their neighbors, or, if you live in Venice, watch ships coming to shore or something. Well, Galileo turned his telescope to the heavens, and in particular, it first turned it to the moon. And there, he described to us in these fantastic drawings and etchings, which he drew himself, these washed drawings on the left and this etching on the right, of what he saw. And here comes an important point. Galileo, he lived during late Renaissance, and he got an education of a person in the Renaissance. In particular, he actually studied drawing, studied professionally drawing. So he was able to do these incredible drawings that we see here. And not only that, he had a very good understanding of light and shadow. So he understood immediately what he was seeing. He understood that he was seeing that the surface of the moon is rugged, that it is covered with mountains and craters, and he said, it's a bit like the surface of the earth. And for example, at the same time, there was an English astronomer named Harriot who also observed the moon with a telescope. And we see his drawings, and they just look like squiggles, and you cannot tell anything. What do you see? Galileo immediately understood what he was seeing. And if you look, for example, at the bottom right, the figure, one of the 6 figures on the left, but the bottom right one, which is marked with the number 3, you see that there are some points of light in the unilluminated part of the moon. Galileo understood that these were tops of mountains that were illuminated by the sun. And, then the sun sort of creeps down the mountain as he does on Earth. So he really understood what he was seeing. Now, the importance of this cannot be overemphasized, because until that time, people believed in what Aristotle told us. And Aristotle distinguished between things terrestrial, which had all kinds of blemishes, could be corrupted and could die even, and so on, and things celestial, which were supposed to be made of this perfect material and to be pristine and with no blemishes and nothing. And here was Galileo showing us that the moon actually looked very much like the Earth. So there was no real distinction between celestial and terrestrial anymore. So he started this thing which today in physics we call, to unify the phenomena of nature and, put them all under the same type of theoretical framework. So he did that. Now, of course, today we have even landed on the moon and we know exactly what its terrain looks like. Here is a picture from one of the Apollo missions, but from orbit around the moon. And we can see this Earthrise, which is so fantastic. You see the Earthrise there, and you can see the surface of the moon, which has hills on it and craters and things and all these things. This was taken by astronaut Blunders. Now, another astronaut, Apollo astronaut, David Scott, did a fantastic experiment on the moon, again to kind of test one of Galileo's theories, and I will show you this short video now, and I will let David Scott describe it.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
So yes, so Galileo argued that if there is a difference between the free fall time of a heavy object and a light object, it only has to do with the resistance of the air, but otherwise they would fall precisely the same way. And here, David Scott did this on the moon where there is no atmosphere, and they really fell together. He then turned his telescope to Jupiter, and this is the first document in which he described his findings to the Doge of Venice at the bottom half of a letter that he wrote. And this document actually is today at the University of Michigan. And what he saw that Jupiter had 4 moons or satellites. And here are his drawings. They describe that. Sometimes the 4 moons were on one side, sometimes on the other. Sometimes there were 3 on one side, 1 on the other, 2 on one side. Sometimes you only saw like 1 or 2, and the others were hidden behind Jupiter. He very quickly understood that what he was seeing is 4 moons or satellites that orbit Jupiter, go around Jupiter. And this was of great significance for 2 reasons. You see, the 2 competing models at the time were between the Ptolemaic, old Aristotelian or Ptolemaic model, in which everything revolved around the Earth, and the Copernican model, which had all the Earth and all the other planets revolve around the sun. Now, those who objected to Copernican model were raising 2 major objections. One, they said, if the Earth is just another planet like all other planets, how come only the Earth has a moon and no other planet has a moon? Well, here Galileo discovered that Jupiter didn't have just 1 moon, it had 4 moons. So that was the end of that objection. Second, again, these people were arguing, well, but if the Earth moves around the sun, how come it doesn't lose its moon? Well, here was Jupiter, and it was revolving around something. Choose, either the Earth or the sun, but it was not only not losing, it was keeping 4 moons. So this objection also dropped. So this was, again, of great significance. Many people don't know it, but Galileo was also the first to detect the planet Neptune. This is the point at the far left here, and he detected it in 1612. Now, he didn't recognize it as a planet because his observations weren't precise enough to actually see the planet move, but he did detect it in 1612. Neptune was officially discovered as a planet only in the middle of the 19th century. One of his most important discoveries was the phases of the planet Venus. The thing is the following. You see, if Venus is orbiting the sun, as the Copernican model claimed, then, and since Venus is between the Earth and the sun, then Venus should show phases. Namely, when Venus is the farthest from us, as it is in the top of this image, it should look the smallest and fully illuminated. If it is, when it is the closest to us, as it is in the bottom of this image, it should be the largest and not illuminated. And in between, it should show all kinds of crescent phases and so on. Just like the moon, the full set of phases of the moon. On the other hand, if it orbits the Earth, that shouldn't happen. By showing that Venus was showing the full set of phases, like the moon, Galileo basically killed the Ptolemaic model once and for all. Now, I will tell you that he did not kill a hybrid model suggested by astronomer Brahe. Brahe, you see, was a great astronomer, but he was still a little bit, captive of the idea that things have to revolve around the Earth. But he realized that this was a problem, and he came up with this hybrid model in which he said all the other planets revolve around the sun, but the sun itself revolves around the Earth. This particular observation did not manage to refute that model, but Galileo never particularly liked this model because it had, being a hybrid model, it had too many moving parts for his taste. So he never really treated it too much. Galileo also observed the Milky Way. Now, this, of course, is a modern picture of a person watching the Milky Way. And there he discovered something also dramatic, which was that, he looked at this, what looked like a continuous band of light, and that broke up into lots of stars of different brightnesses, and, it looked like different distances and all that, hundreds of them. So basically, these were the first observations, into objects outside, if you like, the solar system. So the first venture into, what we would call today modern astrophysics. So he did all of these things, and they were all dramatic, and he really changed the course of the history of science, if you like. I want now to shift a little bit to a different topic because it also is one that is close to my heart. And that is the following. There was in England this chemist and writer, C.P. Snow. And in the 1950s, he started lamenting that he noticed something happening in England. And what was happening was that beginning with the 1930s or so, all the people in humanities, literary scholars, started basically calling themselves the intellectuals, while they were excluding from this group the scientists. And not only that, they were actually mocking the scientists for not knowing much in the humanities and not knowing much in literature and the arts and so on. But C.P. Snow noticed that these same so-called intellectuals actually didn't know very much about the sciences. In fact, didn't know even the most basic things about science. He asked them, what is mass? And they really couldn't really answer, or what is acceleration? So he basically perceived that there is a schism developing between the humanities and the sciences, and he wrote this book, which was called The Two Cultures. Now, today there are those who claim that this schism has even widened. There are some who say that actually it has gotten better, but there is no question that there appears to be a problem here. Now, Galileo, he would not have even understood what C.P. Snow is talking about. I already mentioned that he studied, drawing, just like an artist. And look, he grew up in Florence. he looked one side, he saw the Ponte Vecchio, the old bridge with all its beauty. He looked on the other side of the Arno, he saw this, towards sunset, this fantastic beauty. And Florence was, if you like, the almost birth city of the Renaissance. And so Galileo, not only he lived during the Renaissance, he was really a Renaissance person. At age 24, he already gave 2 lectures to the Florentine Academy on, there's this great Italian poet, Dante, and Dante wrote the Divine Comedy, in which one part is the Inferno or hell. And Galileo gave 2 lectures on the location and structure of the Inferno to the Florentine Academy, already at age 24. Later, he could cite entire passages from Dante. He could cite entire passages from this poet that he really loved, Ariosto. He wrote a whole essay comparing Ariosto with another Italian poet, Tasso, that he thought was very inferior to Ariosto. And some of his best friends were painters. The famous painter Cigoli was not only a personal friend, but even collaborated with him on some observations. And Cigoli, painted this dome in Santa Maria Maggiore in Rome. And I want to draw your attention to the bottom figure here, and which shows the Virgin standing on the moon. But I want you to look how Cigoli painted the moon. He painted Galileo's moon with all the craters and blemishes. Until then, people were actually painting the moon always as this pristine sphere with absolutely no blemishes. But Cigoli knew Galileo, and he knew exactly what Galileo saw through his telescope, and he painted the moon this way. There was this other famous painter. During Renaissance, there weren't that many women painters, but those who were really great painters, and one of them was Artemisia Gentileschi, who was a personal friend and corresponded with Galileo. And she painted this fantastic painting of Judith beheading Holofernes. And she painted 2 versions of this painting. This was the first version. And I want to draw your attention to that part of where the sword is. And story has it that as a result of her conversations with Galileo and him explaining to her that projectiles in the air follow a parabolic orbit, she painted the second version, where she painted the blood squirting from Holofernes' neck. And here it is. And look, she painted it, the blood following parabolic orbits, just as Galileo discovered. And this was her second version of Judith beheading Holofernes. So Galileo was a Renaissance person, not just in terms of the time when he lived, he actually was involved with many other things. I don't want you to be left with the impression that Galileo was a very pleasant or the nicest person. He was self-righteous. He didn't like to be objected to. And he had a very, very sharp pen against all of those who disagreed with him, especially on scientific matters. And I want to give you just one example of one of those exchanges. He was very nice to his own family, mind you, and supported all of them. And he was very, very, he had very good friends with whom he also was in a very good relationship. But boy, if you were an adversary of him, then, I pity you. So he had, there was this Jesuit mathematician named Graci, and he had a disagreement with him on both on the nature of comets and also on the nature of heat in physics. And Graci wrote a book, and in that book he described his ideas about heat, for example. And among his ideas, he actually brought in a story that came from ancient Babylon. And the story was that the ancient Babylonians cooked their eggs by whirling them on slings. So they would put the egg on a sling and whirl it very, very fast, and the egg would heat up and cook that way. Oh, and Galileo heard that. He wrote this book, The Assayer, in which he said the following. It's just as an example of how sarcastic he could be. He said, "Oh, that's how the Babylonians cook their eggs? Very nice. I'm going to believe that. But let's look for a second, because, when we do that, the eggs not only don't cook, in fact, even if they were hot, they would actually cool down if we whirl them like this on slings. So the question is, why is it that this worked for the Babylonians and not for us? So let's try to compare, what the two sides can do. And if there is only one thing that distinguishes them, then that must be the reason for the eggs cooking in one case and not in the other." So he said, okay, so we have eggs just like the Babylonians, and we have slings just like the Babylonians, and we have strong guys who can whirl them very, very fast, and yet they don't cook. So what do we lack? He said, we only lack the fact that we are not Babylonians. So it means that the eggs cook because somebody is a Babylonian. This was the type of sarcasm he was using. And at that point, at that time still, the Pope, which was Pope Urban VIII, who was a friend of Galileo at that time, liked very much this sarcasm and actually had passages from this book read for him at breakfast. But I'm now jumping a couple of decades and to Galileo's problems. Now, I remind you that Galileo was a strong supporter of the Copernican system, in which the Earth and all the other planets revolved around the sun, as opposed to the Aristotelian or Ptolemaic system, in which everything revolved around the Earth. Now, in 1616, the Catholic Church issued a decree against the Copernican model. And not only that, but they issued an injunction against Galileo himself. And in the harsh version of that injunction, Galileo was forbidden from holding, supporting, or teaching the Copernican model anymore. Now, Galileo had in his possession a letter from the chief cardinal, Roberto Bellarmino, that had a slightly weaker injunction, which said that he couldn't hold the Copernican model, but didn't say that he couldn't discuss it or teach it. And he took that to be his guidance. And consequently, he wrote this famous book, The Dialogue Concerning Two Chief World Systems. In this dialogue, this is written as a conversation among three people. One is a stand-in for Galileo and expresses the Copernican view. One was an educated lay person who judges the different arguments. And one who was appropriately called Simplicio, which on one hand was a name of a big supporter of Aristotle, but also had a connotation of being a simpleton, supports the Aristotelian views. Now, in the book, Galileo basically ridicules Simplicio throughout the entire book. But he couldn't publish the book like that because he had to get permission from the church to publish. So in order to be able to publish the book, he added a preface and a conclusion, which basically said, oh, yeah, but actually we cannot tell. These are all suppositions, but we cannot tell. And he even took the words of the Pope himself and put them in the mouth of the Aristotelian, saying that God is almighty and can do thinks however he wants. So, it's not for us humans. We can never really understand how this is done. The problem was that truly anybody who read the book could actually feel that, the preface and the conclusions were kind of written as afterthought, because the Aristotelian views were really ridiculed throughout the entire book. So the bottom line was that Galileo was put on trial before the Inquisition. Now, here is something that I need to explain. Very often people think that the conflict that Galileo was fighting was between science and religion. This is absolutely not true, and Galileo never saw it as such. He himself was a religious person, and he declared that the Bible cannot make any errors. The argument was between science and literal interpretations of the biblical text. That was what Galileo was fighting against. And he noted that the Bible was not written as a science book. He said the Bible was written for our salvation and not to teach us science. And here are some evidence why that is the case. First, he said, the Bible is a book of morals and ethics for our behavior, but the mobility or stability of the earth or the sun is neither a matter of faith nor one contrary to ethics. So it doesn't even apply. Second, he said, you can tell that the Bible was written for the common person to understand and not as a science book, because look, even the planets are not named in the Bible. And finally, he said, I do not think that the same God who has given us our senses, reason, and intelligence wished us to abandon their use. So basically, he was saying, look, whenever there is an apparent clash between literal interpretations of Scripture and what science is telling us, it means that our interpretation is not correct, and we need to change that. Well, that didn't fly because the theologians didn't like a scientist telling them how they should interpret the Bible. They saw that as an intrusion into their province, but not noticing that while saying that, they were actually intruding into science. So he was put on trial, and this to this very day is regarded as one of the most egregious assaults on intellectual freedom, which of course we will see it like this today. At the time, of course, it was seen somewhat different, in particular that Galileo did formally disobey the harsher form of the injunction. So he was put on trial, and there are many paintings that's supposed to represent the trial. This is one of them. It absolutely didn't look like that. There weren't that many people attending. It didn't even look like that, with all the cardinals and others attending the actual trial. It probably looked more like this. There were maybe 3 people in the trial itself, even though the judges were all the cardinals that acted as the Inquisition. There was the prosecutor, Vincenzo Maculano. There was somebody named Febe who took the notes. And there was somebody named Sinceri who actually asked the questions. But Galileo was found vehemently suspected of heresy. Vehemently suspected of heresy was a serious crime, considered a serious crime. And then, the judgment, he was on his knees and they read the judgment. Here again, paintings of him on his knees, how people saw it. Again, there weren't that many people there, but that's how it is. And here is what they said. Decreed that the said Galileo is to be interrogated on his intention. Namely, they were supposed to interrogate him further of whether he intended to write these things which were against what they thought, or was it just a mistake on his part? If he intended, then he would have become heretical and not just vehemently suspected of heresy, for which the punishment was actually to be burnt at the stake, just like Giordano Bruno was burnt at the stake in 1600 during Galileo's life. But in this case, interrogated on his intention, even with the threat of torture, even though, I will say Galileo was never tortured. He was almost 70 years old when the trial happened. I don't think anybody really intended to torture him, but this is what they read. Then is to be condemned to the imprisonment at the pleasure of the Holy Congregation, in order not to treat further on the mobility of the earth and the stability of the sun. He was also never really in prison. This was commuted to house arrest, but he was on house arrest for the rest of his life. So like for the last 8 years of his life, we are going crazy now with the COVID-19, being under partial or full lockdown for a few months. He was under house arrest for 8 years. So this was it. And in order for him to remain only suspected of heresy, he was supposed to abjure. And then again, on his knees, he had to say the humiliating words, "I abjure, curse, and detest the above mentioned errors and heresies." In other words, basically recounting much of his life's work. And so this is why, of course, he was extremely bitter about all of this. Now, it took some 350 years, and things have changed. But by the way, Galileo did finally give his adversaries the finger. When his body was removed from an obscure grave to the tomb where it is today, his remains were moved. Somebody removed some fingers, a couple of fingers, and a tooth, and also a vertebra. And the fingers and the tooth are now again in the Galileo Museum in Florence. But after 350 years, Pope John Paul II finally declared the following: paradoxically, Galileo, a sincere believer, proved himself more perspicacious on this issue than his theologian adversaries. The majority of theologians did not perceive the formal distinction that exists between the Holy Scripture in itself and its interpretation. In other words, the Pope completely agreed with Galileo, but it took 350 years. Pope Francis did the same. Here I am with Pope Francis. The only thing is that this is not the real Pope Francis. It's only a cardboard image of him, but it looks extremely real, and it is at the Catholic University of America. And the Pope said, the Big Bang does not contradict the divine act of creating, and evolution, meaning Darwinian evolution in nature, is not inconsistent with the notion of creation. So two popes now actually agreed with Galileo. Now, you notice that my book is called Galileo and the Science Deniers, and there is a reason for that. And part of the reason is that I wanted to address also science denial today, which unfortunately is rampant. And I'm just going to use one example, which has to do with climate. Now, I'm not an atmospheric scientist myself, not a climate scientist. So I want to stick to very simple things that I can understand, and I think everybody else can understand. And the thing I'm going to stick with is very simple. It's measurements of the carbon dioxide concentration in the Earth's atmosphere, because, that's a greenhouse gas, and that is what causes global warming. And, that there is this discussion between climate scientists and a few deniers whether or not humans have anything to do with that. So I want to just show you these graphs and leave you to make your own decisions. So in the last 50 years, there are very, very accurate measurements of the carbon dioxide concentration in the atmosphere by this scientist killer, and now his son continues that. And this is done in Hawaii. And you see how this carbon dioxide concentration increases. The fluctuations that you see are the daily variations, but it's measured extremely accurately, and you see how it goes. Now, the thing that I want you to pay attention in particular is even not so much the numbers, but the slope of this graph, namely the rate at which the change happens. Because you see, in the atmosphere directly, we have measurements for the past 50 years. But from ice cores taken from Antarctica, we actually, you look at these ice cores, and it's like the rings on a tree, that tell you the history of the tree. Ice cores can tell us the actual carbon dioxide concentration in the atmosphere many, many years backward. So I'm showing you now the same graph for the past 300 years. Now, I want to remind you that the scientific revolution happened in 1848. And just watch what happens to the slope again, the rate of the change from about that time on. And we have these measurements, not just for the 300 years, but even for 10,000 years. And you see that there are changes over, the 10,000 years, but look at what happens, recently, how this graph basically, in terms of the slope, blows out of the graph here. And believe it or not, we actually have ice core measurements going back 800,000 years, almost 1,000,000 years back. And you see that there are changes. There definitely are changes. There are people who say, oh yeah, there were periods in the past that also, yes, there are. But look at the slope of these things over that period of time, and look what's happening now. This is what is happening. So I leave it to you to make your own conclusions from this. But I'm coming now to what I regard as the major lesson from Galileo. This is Galileo's tomb, which is gorgeous. It's in the Basilica of Santa Croce in Florence, and I am actually in front of this tomb. And the lesson is the following. It is never really smart to bet against the judgment of science. And why is that? It's not that science is always right. Absolutely not. Scientists are the first to recognize that all science is provisional. But science has this ability to self-correct. At any given time, science is only as good as the data that are available at the time, but it self-corrects. And sometimes the self-correction can take a few tens of years, sometimes it can take 100 years, but it always corrects. But it is not good to bet against judgment of science in any case. In the case when either the future of the Earth's biosphere is at stake, as in the case of climate change, or when human life is at stake, as in the case of a pandemic, to bet against the judgment of science is absolutely unconscionable. And that is the real lesson that we get from Galileo. So I want to thank you all now, and I hope also that all of you will read the book, because there is so much more in the book than, of course, I was able to say in 1 hour. Thank you very much.
Great. Okay. Now what happens? We
Now
have a bunch of questions. So
yes.
yeah. Are we okay. So I don't think this is the first question though. So is this the first question? Yes. Okay. So here's the first question, Mario. Can you see this question yourself?
I actually can see it, yes. Is it the one that says, what is your strategy facing
Yes.
people who deny?
Yes.
Yes. Yes, I see that. So this is a very good question, and one actually to which I wish I had a better answer. But let me say, the thing is, there are many psychological studies that show that once people are adults and formed an opinion, it is extremely difficult to change their opinion, even if you present them with contradictory facts. So this is a serious problem. So the only way that actually I see to fight science denial in the long run is to start with the education of very young children. And, you know, not everybody needs to be a scientist. Absolutely not. You know, we really need the humanists. We need the literary people. We need the artists. We need all of those. But everyone needs to have an appreciation of what science does for us. An appreciation of the fact, for example, that the fact that we live today, life expectancy today is twice what it was in Galileo's time is only because of science. And the fact that, you know, in our own phone, we have a GPS system which uses Einstein's special theory of relativity and general theory of relativity, you know, and that helps us to get to where we want to go. So all of this is a result of science. We need to teach children and young people this type of appreciation, even if they don't become scientists themselves. Only like that we have a chance in this type of battle.
Great, thank you.
I see the next question. Is there any evidence that Galileo agreed with the idea that the planets have certain influence in the Earth and humans as astrology stands? Okay, so all astronomers at the time also did astrology. He wrote horoscopes, Galileo did himself. However, later in life, he actually has written in a letter that he thought that this was all nonsense and all false. So while he did that for a while, in particular for income, also he was teaching, you know, medical students were all supposed to know to do horoscopes because that directed their treatment of sick people. So they did that, but he absolutely did not actually believe in that. Now, Galileo was actually even stronger than that. He did not even believe in unseen forces that act across distance. So he was even not, for example, he would not have developed Newton's theory of gravitation. And he did not think that the tides were caused by the moon. So he did not really believe on planets that affecting other things. Did Galileo have a specific career or path he intended to go down initially, or was he always a polymath? Well, his father wanted him to be a medical doctor. So he started studying medicine actually at the University of Pisa, but very quickly he discovered that this wasn't interesting for him at all. Well, when he was very young, I should say, he was treated as a, you know, he studied what everybody at the time was studying, which was, you know, some of the arts, some of this, what we would call today liberal arts. But then his father wanted him to be a medical doctor. He very quickly became bored by that, and he heard some lectures in mathematics by a mathematician, Ostilio Ricci, and he really became fascinated with mathematics, and from then on he became a scientist. Any other questions?
Yeah, there's more coming.
I don't see them yet.
Yeah, I don't either. Andrew, can you give us the next question from Doug? It's hidden. I can read it if maybe we lost Andrew. I'm not sure. Oh, here it is.
What do you consider to be the most significant discovery in astrophysics during the 21st century? What do I consider to be the most significant discovery? Well, you know, certainly the expansion of the universe and the fact that the universe accelerates as a result of something we call now dark energy, those are certainly, you know, would rank up there among the most significant. I think that if we were to discover life elsewhere, this would, which I hope actually, you know, will happen within the next 2 or 3 decades, or at least to place some constraints on whether life exists or not in other places. that would be an enormous discovery. But there are many other, of course, important discoveries. But I would say the expansion of the universe, the Big Bang, things like that are certainly rank up there. Let's see. Galileo would not be pleased to know that 380 years later, science is still denied and politicized by creationists and critical social postmodernists. He certainly would not have been pleased. I believe he would not have even understood this. Things like people being against vaccines, this would have been totally baffling to him. What people want to endanger their own lives? I don't think he could have really understood that. What do you think of dogmatic views seen as social sciences and cancel and what? What
Cancel
do you
culture.
of social sciences?
I'm not exactly sure.
I'm not sure I understand the question. I'm against dogmatic views in general, I would say. There is no, look, social sciences, I don't think started as a science, but science is starting to penetrate even into areas that were not originally, treated as science. For example, in social sciences, there is a lot of statistics being done and other such things. How do we know if Galileo was really religious or he was pretending to be religious to stay safe? It's very hard to know. We cannot really question Galileo. But look, he lived in a certain time where most people were religious, one fashion or another. So, it's not crazy to think that he wasn't maybe religious like the Pope. He certainly thought that humans can understand the universe and not that they can never understand the universe. But he did think that the Bible was a good guide for ethics and so on. Most of the reviews of the book seem to want more in-depth discussion about the science deniers today. Do you intend on discussing more of that in future work? I don't know if most of the reviews do that. Actually, there were a couple of reviews that say that maybe I should have not even introduced that in the book. No, I don't intend to write another book on that. But I certainly, like today, I certainly am happy to discuss the question of science denial. What do you think would be a good start in helping to close the gap or schism between science and humanities you talked of earlier? Yes. So look, what I'm doing today is part of that, I think. Yes. Writing popular science books, which means, writing books, like this book, yes, Galileo and the Science Denier, which people who are from other areas can actually read. And, this entire interdisciplinary project that University of Manitoba is doing is exactly the kind of thing that I think should be done. And I noted also the education system should teach the scientists some of the humanities and the others, the people from the humanities, an appreciation of the sciences. Why was Galileo not more receptive to the findings of Kepler? Well, he was receptive to some of the things initially, but other things he wasn't. So, for example, as I said, he didn't believe much in forces acting, unseen forces acting across distance. So while Kepler, for example, definitely thought that the moon has something to do with the tides, Galileo didn't accept that. Kepler found that orbits of planets were elliptical. Galileo didn't accept that. But that's because even though he was such a great scientist, he was still, a little bit a prisoner of the old ideas. It thought that the orbits have to be perfect circles because that's the most perfect thing. There wasn't still the notion that it is not the shape of the orbit, but the laws that need to have such symmetries. What do you think of the Hegelian dialectic in regards to science being thesis and science denying antithesis? Could you please elaborate? Yes, I actually think that Hegel has a point there, definitely. But the slight problem is that, like all ideas in philosophy, and in particular German philosophy of that era, they are some of the propositions cannot be proven in a way that a scientist would accept as a proof. So I'm a little bit always ambiguous about this, but it certainly was a very clever person. What was his views on chemistry or alchemist? Well, unlike Newton, who actually really wrote about alchemists and things, Galileo did not. So he was not. He didn't know that much about chemistry. In his discussion of there is a discussion that he has on the nature of matter, which also annoyed the church very much, because it seemed to object to object to the miracle of the Eucharist, of the changing of water into wine and things like that. So he, I would say he had some views on the nature of matter, which did not quite agree with those of the church. What is your advice for students who are discouraged by not having any hope for discovering anything significant due to all simple phenomena being discovered? I don't think that actually that is entirely true, because I want to remind people that there is a story that in 1900, Lord Kelvin, who was the dominant physicist of the second half of the 19th century, allegedly declared in a meeting that all of physics is now done and all that's left is just more precise measurements. And just 5 years following that, Einstein came with a photoelectric effect, which introduced quantum mechanics, and special relativity, which introduced a revolution in our understanding of space and time. So you never know. Look, at the moment, for example, we don't have a unifying theory of gravity and quantum mechanics. So that's a huge task that maybe somebody can do one day. So I would say that's at least as significant as almost everything that was done until now. So there is still a lot to do. Okay, are we? Oh,
One more, last one.
Okay, what role did Greek philosophy play in Galileo's discoveries? Okay, so Galileo was a huge follower of Archimedes. He thought that Archimedes was like the ultimate scientist. Now, Archimedes, mind you, was certainly one of the absolutely greatest mathematicians to have ever lived. And not only that, he did things in pure mathematics, but he also applied mathematics to physics and to real life phenomena, like war machines and things like that. And that partly influenced Galileo in thinking that the whole universe is written in the language of mathematics. So this certainly had a huge influence on him. He also was very familiar with what Aristotle said, even though he objected to most of what Aristotle said.
All right. Well, thank you. This has certainly been a wonderful seminar, and great questions by our audience. So thank you all, audience, for such a stimulating set of questions. And I'll clap for all of us to Mario, and thank him for his wonderful participation this afternoon, and wish all our Canadians happy Thanksgiving. Yes, there's something written for us. Yeah. And the Americans have to wait a little longer for their Thanksgiving. But,
yes, so happy Thanksgiving, and thank you very much for having me.
Okay, great. Thanks, everyone.